Hi everyone, this is a video on how to create a script that will be put in a pipeline in GeoBond's Bond-in-a-Box modeling tool. The first step is to create an R, Julia, or Python script in your code editor of choice. I am using R in the Visual Studio Code program here. I am opening Visual Studio Code to the Bond-in-a-Box pipelines folder here. You can save this script with an informative name. Create the R script in the Scripts folder of the Bond-in-a-Box Pipelines folder. You can also create a folder within the Scripts folder to hold all of your scripts in your pipeline. Create a file with a .yml file extension. This is going to be a description file of your pipeline that will contain the information of the inputs and outputs of your script, as well as a description of what the script does. The syntax of a YAML file is sensitive to spacing and indentation, so make sure to have the correct spacing. Write the script and the name of the script that you are describing. Here I called it testscript.r. Next, write the name that you want to show up in the UI of Bond-in-a-Box. This should also be a descriptive name. Write the description of the script. This can be as long as you want and can include links and photos. Here I'm going to write, this script is to demonstrate how to create a YAML file and an R script for Bond-in-a-Box. Next, write the author of the script and their org ID. This can also include multiple authors. You can also copy, paste, and fill in these fields from the example script in our documentation, which is linked below. The next step is to define the inputs of the pipeline. There are two types of inputs in Bond-in-a-Box. One is an input that appears on a form that can be filled in by the user. These are the parameters that you want the user to be able to specify in the pipeline, such as species, study area, etc. The other type of input is one that comes from the output of another script. These inputs will be connected to outputs of other scripts in the pipeline editor and can be in a variety of file formats such as GeoJSON, CSV, etc. Load the packages that you need for the analysis. First, load RJSON because it is necessary for every script for the pipeline engine to be able to read the JSON file that goes along with every pipeline. I am doing a spatial analysis, so I will load SF and Terra. I will also load dplyr for data manipulation, and ggplot2 for plotting. Use the biab_input function to allow the script to read the inputs from the JSON file. Now it is time to write the script itself. Let's say I want the script to load a shapefile of the country of interest. I am going to code this as I usually would, using the stread function in the SF package. But instead of loading the file using the file path, I'm going to write input $country_polygon. This will be the syntax for all of the inputs, input $, and the input name. Now I'm going to add this input to my YAML file. I will show you the syntax to do this. First, I'm going to write inputs, and then return an indent. Then I write the name of the input as it appears on the R script. I will write country_polygon here. Next, I will write the name in a more readable format. This is how it will appear on the pipeline in the user interface. Next, I will write the description, which will explain more about what kind of input it is, so users can easily fill it out. These can include pictures or links. Next, I will write what the file type is. There is more information about the kinds of file types that are accepted in the documentation here. I'm going to use the GeoTIFF document type, which is a cloud-optimized geospatial format. I am going to go back to my R script. Next, I want to transform this data into a different coordinate reference system that is specified by the user. So I am going to transform it and add the input as input $CRS. I can add this to the YAML file as another input. I will make the name coordinate reference system and write the description. Then I need to choose a file type. I will write text here so the user can type the input into the input form. Then I will add the example of EPSG 3857. This will autofill in the form unless the user changes it. But let's say I only want the user to be able to choose from 2 options for an EPSG. Then I can make the type options and add the options here. Now I am going to add an input of an array of raster layers that I will pull from the stat catalog. I am going to perform some functions on these raster layers, including cropping them by the country polygons, looking at the difference in the 2 raster layers, and taking the means of the cropped raster layers. I'm going to add the raster change as an array of GeoTIFFs. I am going to add the raster input as an array of GeoTIFFs. An array is specified by these brackets at the end of this file type. Next step is to define your outputs. This is what you want the results of the script to be. This can either be a final output, such as an indicator value or map, or this can be an intermediate output that will become an input to another script. The output file types can be found on the How to Contribute documentation. These can be a CSV, a GeoJSON or GeoTIFF file for spatial data, an HTML page, or a JPEG or PNG for plots. The first step is to decide on the outputs that you want in the script. The first output that I want is the raster that shows the difference between the 2 input rasters. The first thing I will do is define the path, which is always the same. It is just the file.path function with the output folder and then the name and file extension I'm using. So here I will call it raster_change.tiff. Now I will write the output using whatever function is normally used for that file type. In this case, using the write_raster function in Terra. I will specify the file path as the one I just wrote above and the name of the file. Now I am going to write the output so that it can be read by the pipeline engine. This is done using the function biab_output. Within this function, I will write the name of the output, which I called raster_change above. Make sure that this is in quotes. Then I will write the file path, which I called raster_change_path. Next, I will do the same thing with the other output that I want, which is a plot. I will use ggsave to save the file now and output it in the same way using the biab_output function. Now I need to add these outputs to the YAML file. This is done in a very similar way to the inputs, except there are some file types that can be outputs but not inputs, such as photo files like JPEGs or PNGs. I will write outputs here. Make sure it is in line with the inputs because YAML files are tab sensitive. Next, I will name the output. It is important that it has the same name that is specified in your R script. The rest is the same as the input, except there is no example. Now I can write the output for the plot, which I want to be a PNG file. The next step is to code errors. This is a tricky process and will likely take several iterations as you test the scripts and pipelines and discover more common errors. Normal R errors will appear in the user interface for debugging, but R error codes are not always informative, so coding common errors is a way to help the user of the pipeline better understand. For example, if you have a script that pulls a shapefile of countries from an online source, and one of the inputs is the name of the country, users may misspell the country name, but the error R would give would have something to do with an empty shapefile, not the misspelling of the name. So you could code the script to recognize this error and tell the user to check the spelling of the country. The way this is done is to use a condition message and then use the function biab_error_stop with your error message, in quotes. Here I am going to make a condition message for when the country polygon input shapefile is empty. This is going to stop the script and give this error message telling the user to check the spelling of the country. The next step is to add the Conda environment. Conda makes sure that the code doesn't break when packages are updated by allowing you to specify package versions. The pipeline engine has a central Conda environment that includes commonly used packages. Instead of installing the packages in the R script directly, the packages are installed with Conda. The first step is to check if the packages that you need are already in the central R environment. You can do this by going to the renvironment.yml file and looking through the packages that are there. If all the packages that you need are in the central R environment, you do not need to specify a Conda sub-environment in the YAML file, and you can skip this step. In this case, the package ggplot2 is not in the main environment, so I will need to specify a sub-environment. I will start with the channels, which will be Conda, Forge, and R. It is important to make sure Conda Forge is listed before R. Then I will start listing the packages and dependencies. Make sure you list all of the packages that you need, not just the package that isn't in the main R environment file, because this is making a sub-environment for the script. Let's say I need a specific version of Terra for this script. I would write the package equals and the version number here. The next step is to document the script. First, it is good practice to comment throughout the script what you are doing so that a person looking over the code can more easily understand. I will go through and add comments. Next, I will add messages throughout the code using the print function so that when there is an error, the user can see how far the script got before crashing. I am just adding some messages that the polygon was successfully loaded and the raster was cropped by the country polygon. These messages will appear in the R log in the user interface. Next, I will add some references to the YAML file of the script. I will put the text of the reference and the DOI link like this. I will connect to the server using the server-up.sh function. You can see that my pipeline appears on the side here with the name I gave it in the YAML file. If I click on it, I can see the information that I wrote, including the author, description, link to the GitHub code, and references. When I go to the Run Script tab, I can find my script in the drop-down menu and see the inputs and outputs here in the user form. You can see that the examples autofill when they're provided. Now it is time to test the script. It is generally easier to test the script on its own, but this can also be done as part of a pipeline. I have put some files in the user data folder of the Bon in a Box pipelines folder that I will use to test my script. Then I will navigate to the Single Script Run tab in the pipeline engine. I will input my first dataset, which is a shapefile of Canada, using a file path with the Bon in a Box pipelines folder as the root. Then I will input 2 TIFF files. Because this input is an array, I can input 2 files separated by commas. Now I press Run Script and wait for it to run. My script is done running and it worked. I can look at my outputs here, which are a plot of the means of the rasters and the plot of raster change. Note that if I click on the underlined paths, it will download the outputs to my computer in the specified file types. Now I will show you what it looks like if there is an error. Say I commented out the code to load ggplot2 in the R script and reran. It would give me this error at the top that says cannot find function ggplot, so I would know to fix that. Another example is if I miswrote one of the variable names. Again, it would give me an error saying that it could not find that object. And this is how to write a script. Thank you for watching. To connect these into pipelines, please see our video called How to Build a Pipeline. To learn how to install the program, please see our video How to Install. If you have any issues, please refer to our documentation or email us at boninabox@geobon.org.